Hello, my little mathematicians. Today, we're going to work on solving word problems using proportions. First off, I want us to talk about how we did already learn how to solve word problems using unit rate, and sometimes unit rate is the thing that we want to use, but other times using a proportion would be better. So, of the 8 problems on this page, and the next page right here at the top, I want you to look through and see which ones you think would be best to do a proportion and which ones would be best to do by unit rate. Okay, so number 1 says the Wilsons went on a road trip. They traveled 420 miles using 12 gallons of gas. How many miles did they travel per gallon? Remember that the unit rate is finding how much it is per one of something, right? So they just want to know how much is it to go 1 gallon, or how far would you go per 1 gallon of gas? So this is actually a problem where all we would need to do is do 420 miles over 12 gallons of gas. And then I would divide by 12 to get my unit rate. So this is one where I would do the unit rate. Okay, we don't need to actually solve it. I only want us to solve the ones with proportions. But identify there's 3 more that unit rate would be the best thing to do. Okay. Remember, you can always pause the video, try to figure it out yourself, and then unpause it and come back. Okay, if you're back with us, number 2 says Ashley bought 3 shirts for $44.55. If each shirt cost the same amount of money, how much did one shirt cost? Well, again, they want to know how much one shirt cost, right? So we want the number of shirts to eventually become 1. So we'd put the money over shirts. So it would be $44.55 divided by how many shirts you got. So you would divide it both by 3 and you get how much it is per one shirt. So this is another problem where we would just need to do the unit rate. Okay, the next one says the bus driver travels 220 miles in 5 hours. How fast is a driver traveling per hour? So miles per hour, and they want to know how fast he goes per 1 hour. So eventually I want the number of hours to become 1. So again, I'd just be finding the unit rate. I would divide both of these by 5 to get that. Okay, for this one, it says at the store, a pack of 8 juice boxes cost $3.92 and a pack of 12 juice boxes cost $5.40. Which is the better deal? Whenever you have like what's the better deal or what's the better buy, those types of problems, you want to find the unit rate of each. So this would be $3.92 for 8 juice boxes, and the other one is $5.40 for 12 juice boxes. So you divide both of these by 8 and you divide both of these by 12. And then you figure how much it is per one juice box, how much it is per one juice box here, and whichever one is cheaper, that would be the better buy or the better deal. So again, you'd be finding the unit rate, only you're finding the unit rate twice because you're finding the unit rate of this one and the unit rate of this one and then comparing which one's cheapest. Okay, so all of those are unit rates. And since I gave you the hint that there was only 4 where unit rate was better to solve, we kind of figured out now that the rest are proportions. So let's see why these ones are better to solve as proportions than the other ones. Number 5 says if there are 375 calories in 5 servings of cake, how many calories are in 2 servings? Well, notice that it didn't say how many calories are in 1 serving, so I didn't just want to find the unit rate. Here, they first of all gave me enough information to do one proportion. You know, you have calories on top, which is 375. And then you have how many calories come with each serving. So for 375 calories, that's 5 servings of cake. Okay, and then they don't just ask me like, hey, so then how much is it per one serving? So divide both by 5. Instead, they're saying, okay, well then how many calories would you get? So we don't know how many calories if you were to eat 2 servings yourself. Okay, so 2 went on the bottom because that's where servings are. And then the X was my unknown because I don't know how many calories there are. Notice that we put calories on top, servings on the bottom. These ones went together. It was 375 calories for 5 servings. And then we don't know how many calories are in 2 servings. Now, yes, there are multiple ways to set it up. Like you could have put the X over 2 first and then the 375 over 5 as well. And there are a few other ways, but this is the easiest if you stay consistent of calories on top and then servings on the bottom and keep your items grouped together. Now, once you have your 2 ratios set equal to each other, and I was consistent in how I set them up, then you could either see, okay, 2 times what is 5? It doesn't go in evenly, right? So I might want to do cross products, which means I would take 5 and multiply it by x and set that equal to the 2 multiplied by 375. Okay, so again, whatever's diagonally across from each other, you set those to be multiplied together. So 5 is going to get multiplied with x, and you're going to set that equal to 2 multiplied by 375. Okay, well, I can't simplify this side anymore, but on this side, 2 times 375 is 750. Okay, so now you have 5x equals 750. Once I have that equation, how do you get x by itself? Well, the 5 and the x are being multiplied, and the inverse of multiplying is to divide by 5. Because anything divided by itself is 1, and now you have 1x equals, well, I can divide randomly by 5 as long as I divide by 5 on the other side, right? So I want to keep that equation balanced. So whatever you do to one side, you have to do to the other. Now I have 750 divided by 5, and that equals 150. And X stood for the number of calories, so it's 150 calories. Now, cross products will always work. It's helpful, especially if there's like repeating decimals and stuff when you try solving. But for this one, we actually still could have done the easy shortcut. Okay, go towards your unknown. And yeah, it doesn't go in perfectly evenly, but if you divide 5 by 2.5, isn't that 2? Yes, it is. So if I'm dividing this by 2.5, divide this by 2.5, because it's kind of just like you're reducing this fraction, right? And so then what would this unknown be? Well, 375 divided by 2.5, if you plug that into your calculator, you also get 150. Okay, so you can do this shortcut. Just remember to always go towards the direction of your unknown right here. So go this way, not this way. So instead of going 2 times something, it's 5 divided by something to get the 2. Okay. Now, if it was something and it was when you type it into your calculator, it's something repeating, then you would want to solve by cross products. Okay. But if it's not something repeating, why not do the shortcut and then bypass all of this? Okay. For my next one, it says Rebecca is training for a long distance race. If she can run, what does it say? 24 miles. So we're talking about miles first, and she can go 24 miles. And how long does that take her? It takes her 6 hours. So the bottom's talking about hours. So 24 goes with the 6. And then it says, how long will it take? Well, we don't know how long. So that's my variable. And the time, how long it'll take, is on the bottom. So there's my x. Will it take her to run 36 miles? So 36 is talking about the number of miles she can go, and that's on top. Okay, now can you do the shortcut? Can you go this way? Can you go from 24 to 36 easily? Not really. I don't know, 24 times something to get 36. So let's do the cross product way. Okay, this is diagonally across from this, so I'm going to multiply those two, 24 times x, and set that equal to these two that are diagonally across from each other, 6 times 36. Okay, well, I can't simplify this side anymore, but I can simplify 6 times 36, plug that into your calculator, and you get 216. Okay, now I have a basic, easy equation. How do you get x by itself? Well, I need to get rid of that 24. And that 24 and x are being multiplied with each other. And the inverse of multiplying is to divide. Because anything divided by itself is 1. And now you have 1 times x. Woohoo, x is by itself. I can do that as long as I do the same thing to the other side. So type in 216 divided by 24, and you'll see you get 9. Now, what was x talking about? X was talking about the number of hours. And double check that that's what your question was asking. It said, how long will it take? So yes, hours make sense to be my unit because how long will it take requires that it's asking about time. All right, let's see how we do on the next page. Okay, the next problem says Sam scored, let's see so you can see, Sam scored 14 goals in 7 soccer games. If he continues to score goals at the same rate, how many goals will he score in 10 games? So I'm talking about the number of goals, which he scored was 14, in regards to how many games played. So goals per game. Well, in 14, he scored 14 goals in 7 games. So then the next sentence is saying, okay, if he continues to score at that same rate, how many goals? So we don't know how many goals. So that's my variable, and goals is on the top. So my variable's on the top. Will he score in 10 games? Well, 10 games is on the bottom, so 10 goes here. Now, can you do the shortcut for these two ratios that equal to each other, aka a proportion? To 7 times anything equal 10? Not really. So I'm going to have to do my cross products. So 7 is across from x, so multiply those, and set that equal to these two cross products that are across from each other, the 14 and the 10. So again, you multiply these two and set them equal to these two multiplied together. 7 times x can't be simplified, but 14 times 10 can. That's 140. Now, how do you get x by itself? I need to get rid of that 7, so I'm going to divide both sides by 7. 7 divided by 7 is 1, and 1 times x is x, equals, well, 140 divided by 7 is 20. And x was talking about the number of goals. And it even says how many goals. So perfect. There we go. I just solved it. If you haven't paused the video and tried some yourself yet, please make sure you do that for this one. Okay, now you paused it, and then you unpaused it, you're back with us. Let's see how you did. Okay, for this one, it says Eve is mixing green frosting. Okay, in order to make green frosting, the recipe calls for 1 drop of yellow food coloring. So we have yellow, and that requires 1 drop, for every 3 drops of blue food coloring. So yellow to blue. The blue had 3. So then they want to know if she used 6 drops of yellow. Okay, so 6 is going to go on top because that's where yellow is. Then how much blue should she add? We don't know how much blue, so I'm going to keep that as a variable. Okay, can I do the shortcut? Can I go from 1 to 6? And again, I don't want to go from 6 to 1. I want to go from 1 to 6 because you always go towards the direction of your unknown. Well, yes, I can go because 1 times 6 is 6. So then do the same thing on the bottom. 3 times 6 is 18. So she should use 18 drops of blue. Now, if for some reason you didn't see that, you could still do the cross products. 1 times x is x. Set that equal to 3 times 6, Well, 3 times 6 is 18. So again, 18, and X is talking about the drops of blue. So notice how even if you do the shortcut or if you do cross products, you still get to the same answer. It's just cross products will always work, even if your numbers aren't very nice. And the shortcut, if you can do it, why not? Now, I tend to always do where you put the same thing on top and then the same thing on the bottom. So we put all the things relating to yellow on top and all the things relating to blue on the bottom, goals on top, games on the bottom. And then you always put like whatever you're talking about first here and whatever you're talking about second here. To me, that just makes the most sense. But there are actually a lot of ways to set up a proportion. Now, there are wrong ways to set up a proportion as well, but there's lots of different ways. There's usually, in fact, 2, 4, 6, 8 different ways to set up a proportion correctly, as long as you're consistent. So let's show you for this problem right here, okay? First of all, we'll do the ways that we're comfortable, okay? So it says you have 2 bags of chips, so the bags, okay, for $6. And this is why I like proportions, because it doesn't really matter what goes on top or bottom as long as you're consistent. So 2 bags of chips for every $6, okay? Then the next sentence is saying, so what would, actually money's blue, what would the cost be? So we don't know the cost if you're doing 10 bags of chips. Well, 10's talking about the number of bags, so 10 will go here. Okay, so this is one way to set up the proportion. This is what we're familiar with. Okay, now if you had done, okay, they talked about bags first, and then they talked about money, but you like to focus on what they're asking first. So maybe you did, okay, what would the cost be for 10 bags if 2 bags of chips cost $6? Okay, notice that you still have 2 across from the X. 2 is across from the X, and 6 is across from the 10. Okay, you're still bags of chips on top, money on the bottom, and like these two go together right here, and these two go together here. So those are the most familiar ways. Okay, also, what if, a lot of people are like, no, money always goes on top. Okay, so they just like to have money on top and then the number of bags on the bottom. Okay, and the first person's like, this came first, so I want this to be the first proportion. So 2 bags of chips cost $6. And then how much would it be for 10 bags of chips? And other people like to focus on, like, the problem they're actually being asked first. So like, okay, 10 bags of chips, we don't know how much that costs, but we do know that it costs $6 for every 2 bags of chips. Notice again, you still have 2 across from the X, and 6 is going to be multiplied with a 10. 2 is across from the X, 6 is multiplied with a 10. Just up here, 6 is across from the 10, 2 would be multiplied with the X, 2 would be multiplied with the X, and 6 is across from the 10. So you notice that like they still end up having the same cross products because I was consistent. I had bags on top and money on the bottom, and I talked about these both went with the first sentence, and these both went with the second sentence. Or some people like to focus on the second sentence first, then they go back to the first sentence. Okay. The other way that I don't like quite as much, but some people do, they instead like to do it kind of like column wise, where they'll go, okay, I'm going to put all the money stuff first. So I have, actually here, let's keep the colors the same. I like to talk about money first. And so they said, like, I was given the $6 first, and then we don't know the other cost. And then I'm going to put my second proportion to be talking about the number of bags. Now, here's the thing. When you do it this way, then you have to be consistent across. So 6, what was 6 going with? It was $6 for 2 bags, right? And then we don't know the cost of 10 bags. Notice 2 is still across from the X, 6 is still across from the 10. So here they did the money as the first proportion, the number of bags is the second proportion, and here they talked about the first sentence on top and the second sentence on the bottom. Okay. If you want to keep doing columns, let's say again, we had money first and the number of bags as the second proportion. Okay, but this time, instead of doing the first sentence on top, they did the second sentence on top and the first sentence on the bottom. So that would look like how much would the cost be when you buy 10 bags versus it would be $6. Okay, we're still talking about money for 2 bags. Okay, I stayed consistent. Now here we put money first. What if this time I put the number of bags first and then I put money second? Okay. Again, we'll have the first sentence over the second sentence, and then we'll try the second sentence information and then the first sentence information. So this one would look like, all right, I have 2 bags and that costs me $6 versus if I have 10 bags, we don't know how much that costs. Okay, the other way, the final way would be 10 bags would cost me, I don't know. But I do know that 2 bags cost me $6. Okay, so do you notice how each time we're really consistent? So here I have like the bags and then the money, and this is all the first sentence information, and this is all the information from the second. And if you're like, so is it only columns where that matters? No, like even here, we do it without thinking, but this came from the second sentence, 10 bags would cost how much? And then this came from the first sentence, 2 bags cost $6. Okay, again, here, this was the second sentence. This was the first sentence. They just switched. Money was on top and bags were on the bottom. Okay, and then here, this is again the first sentence, and this is the second sentence, but they had bags on top and money on the bottom. We just flipped first and second versus second from first. Okay, and here we're doing the first sentence and then the information from the second sentence, only this time we have money on top and bags on bottom. So do you see that like we're all consistent both in rows and in columns, what we're talking about and where we get the information from, that they go together. So like, the 10 goes with, we don't know the cost, and the 2 bags goes with the $6. All of these proportions are set up correctly. And so when you go to solve them, you would still get the same answer. 2 times what is 10? 5. So 6 times 5 is 30. 2 times what is 10? 5. So 6 times 5 is 30. This time, if you go towards the unknown, it's over here. 2 times what is 10? 5. So 6 times 5 is 30. I think you see the point. And even if you were to do cross products, 2 is across from the x every time. There, there, there. And 6 is always across from the 10. Okay, so now that we've established there's a lot of different ways to set up proportions, I just typically like to do this way. Let's see these people and see who set it up correctly and who made a mistake and wasn't consistent with how they set it up. All right, so we have Ingrid, Jack, Kira, and Lee. The question is saying Holly sells fancy cookies. She sells 8 cookies for $6.24. Then they want to know 12 cookies is going to cost me how much? This is the first piece of information, so it should stick together. And this is a second piece of information, and it should stick together. Well, Ingrid, 8 and 12, those are both cookies. So she did it the column way, where she has cookies here and then money here. Did she stay consistent? So this should both be from the same piece of information. Does 8 cookies cost $6.24? Yes, it does. That's from the first sentence, and this is from the second sentence. We don't know how much 12 cookies costs. So Ingrid is good. Okay. Here we have Jack, and he did 12 and 8. So we still have the number of cookies here and the money here. But this time he did the second sentence information on top, because 12 cookies, we don't know the cost. And then the first sentence piece of information, 8 cookies, cost $6.24 on the bottom. Okay, Kiara did 8 cookies for $6.24. So she did cookies on top, it looks like here. Was that consistent? 8 cookies and 12 cookies, yes. And then money would be on the bottom. $6.24, and we don't know the money. Correct. Okay, now was she consistent that these go together? Yes, 8 cookies cost $6.24. Those both came from the first sentence, and we don't know the cost of 12 cookies came from the second sentence. So she's consistent with all of her information of how it's laid out as well. Okay, let's see. Maybe they're all correct. Lee did 8 and 12. So he did cookies. And then he did the 2 monies. Okay, and let's see. Do we not know the cost of 8 cookies? Actually, we do. So it looks like this was from the first and this was from the second. So it's not like, since we did these, then these have to both be from the first. But he did that. This is from the first. This is from the second sentence. And this is from the first sentence here. Like it doesn't line up. So he wasn't consistent with the way his information was laid out. So Ingrid, Jack, and Kira all did it correctly, and Lee did not. Okay. Now, when you go to explain why, these people were all consistent in how they laid it out. They kept cookies together and money together, whether it was by rows or by columns, and they kept the pieces of information from the second sentence together and the pieces of information from the first sentence together, because 8 cookies is $6.24. We're trying to figure out the cost of 12 cookies. All right, hopefully this helps you see a little bit better how to go about setting up your proportions when trying to solve word problems. You've got this, my little mathematicians.